In this lecture, we're going to talk about the Newton law of universal gravitation. Basically, this law shows the gravitational force between two masses and the concept of distance in it. So, there's a statement. Gravitational force of attraction between two masses is directly proportional to magnitude of masses. Now, let's suppose it's a mass 1 and it's mass 2. Now, according to the universal gravitational law, if the mass is greater, the force between these two masses will increase. As the mass increases, the force will also increase. As it is just written, two masses is directly proportional to magnitude of masses. Like attraction is directly proportional to masses and inversely proportional to square of distance. Like if distance between these two masses is greater, the force will be lesser. If the distance is lesser, the force will be greater. Or we can say that if the mass of these two objects or these two things is greater and the distance is also greater, so the attraction will be lesser because force is inversely proportional to the distance. Now there's a mathematical representation of this law, that is F is directly proportional to m1 and m2, as we just learned about it. M1, m2, the greater the mass, the greater the force. So the force is directly proportional to m1 and m2 and inversely proportional to the distance. The r represents the distance. As we talked about that if the distance of these two masses is greater, the force of attraction will be lesser. As we know, if we remove the sign of the proportionality, what we will add? We will add a constant. There's a gravitational constant written in the place of proportionality, and this gravitational force shows a significant constant value of the force of gravity, which is 6.67 10 raised to power minus 11. Like the force of these two masses is, we can say that the gravitational force will be 6.67 10 raised to power minus 11. As if the masses and distances improve, this value will also improve, I think. So, the Henry Cavendish just discovered this theory. Now, every equation has a dimension. So, let's find out the dimension of this equation. Now, as we know, F is equal to G m1 and m2 and r square. So what if we want to find the value of the gravitation? What we will do, we will just derive the formula to find it from this equation. What it will be? G, we can say that F is equal to m1 and m2. We know that the distance is multiplying here, so we will just transfer it to another side and it will become Fr square is equal to G m1 m2. Now here m1 and m2 is multiplying. By going there, it will just divide, so we can say that G is equal to F r square upon m1 and m2. Now, that's the formula to just find the gravitational constant. Now, we just gonna find the dimension of the gravitational constant. So what we will do, we know that F is force and the unit is Newton as it is written. Distance is measured by meter and there's a square on it, so we will write it as a meter square. Now by dividing it, we will just represent the masses, which are there are two masses stated, so we will just say that the masses will be squared. Now we know that what's the dimension of the F. Actually, the dimension of F is mLT minus 2. You know that m represents the mass, L represents the length, and T represents the time. So, what's the dimension? What will be the dimension of m? Actually, m just represent the meter, and meter is unit of a length. So we can say that it will be the length. We will just divide it by the kg. The kg represent the mass, and we will just square it. Now this mass will be cancelled by this mass, and what we will get is, where should I write? Okay. Now we can write it as a L2 m minus, here it is, now it's plus 2, so it will become minus 1 and T minus 2. Now it's the dimension of the gravitational constant. Now there are some key points here which is related to this equation. Now line joining from their centers, if mass A, mass B, how can we distinguish the distance between them? We will not measure it from here, we will measure it from the centers. Okay? We will not measure it from here. Okay, now mutual force, like the force of m1 to the m2 is same as the force of m2 to the m1. Okay, the force is equal. Now the third point is F12 is equal to F21. It is same as this. What will we just say? M1, M2. The force that the M1 is applying to M2 will be equal to the force of M2 applying to M1. Now, what's the concept of Newton's third law in it? As we know, the Newton's third law just states that action has an reaction. So, what's the concept of it? We can just say that if M1 is applying force to M2, so as an reaction the M2 will also apply force to M1, and that's the Newton's third law. So we can say that it is valid in the gravitational constant. Now there are some more points. Independent of medium. M1, M2 is just gravitational force is just independent because it does not need any medium. It just works like as a wave. Or we can so say that it cannot be seen, it cannot be touched, it can just I think sometimes it cannot be felt as well, but it exists. So we can say that it is independent in medium. No medium needs. It will work in vacuum as well. So now there's a point masses. What is point masses? If M1 is at distance of M2, no matter how the mass is increased, the greater the mass, and it also has a greater mass. No matter how the mass is or what the mass is, if distance is like distance is greater, the mass will not affect. As we had talked, the force is inversely proportional to the distance. If the mass of the m1 is at the distance from the mass of the m2, so the mass of the m1 will be the point mass to the m2. These will be point masses. Like I'm sitting here, I'm point mass to you because I'm at a distance with you. Now, here's a point significant. Heavy bodies like sun, moon, earth, like these type of heavy bodies can now we can observe the gravitational force by just studying on these type of heavy bodies. Now the last point is torsion balance. Now this is a type of a balance like if we just hang m1 to the m2, so no matter how the mass is, that if the mass is greater, it will just not affect on that. It does not have a effect. The m2 and m1's distance will matter. So that's called the torsion balance. And that's about the gravitational